Hi everyone. In this video, we are going to discuss how to rotate matrix counterclockwise. We are given a matrix of n by n, which are of all are integers, and we call this matrix as M. And we need to write a code that rotates this matrix by 90 degrees in counterclockwise direction. And the condition is we should not use any extra space. We should do this within the given matrix. We should not create or declare any new matrix. So that's the challenge. And here we can see an example here and understand what it means by rotating the matrix 90 degrees in counterclockwise direction. So we have a matrix here of 5 by 5 matrix. You can see the elements of the matrix here, and what it means by rotating the matrix 90 degrees is, so let's understand it by taking the first row here, which has 1 2 3 4 5 as elements. So when we rotate this row 90 degrees, you can see the output here in the rotated matrix. So it comes, one comes in the last row of the first column. You can see 2 above it, 3 above, 2, like this. You can see in the rotated matrix here. So in the same way, each row will be rotated. And you can see the output in the rotated matrix, which we call it as a matrix rotated 90 degrees in the counterclockwise direction. So this is the matrix, given matrix, and this is the rotated matrix, or this is the expected matrix we wanted, right? And how to solve this problem is, we have two solutions for this. So let's first discuss the first one, using the matrix transpose. In this approach, we'll first find the transpose of the given matrix. And what does that mean by transpose of a matrix is, it's a notion from linear algebra in mathematics, which means we need to flip a matrix over its main diagonal, which results in a new matrix, which we call it as the transpose of the matrix. You can see that in this example, right? So this is the original matrix M, and we can see a line drawn on the main diagonal. And flipping the matrix right over its main diagonal means swapping the elements of the matrix of ij. Say for example, I denotes row and j denotes column, then we will swap the elements ij with ji, meaning ith row jth column will be swapped with jth row ith column. For example, you can see here, let's take 2 here, which is at location 0 comma 0 representing row and 1 representing column, 0 1. So it will be swapped with 1 comma 0 first row, second 0th column. You can see here 2 and 6 got swapped. In the same way, 3 and 11 get swapped here, and 16 and 4, and so on, right? So this is what we mean by flipping the matrix over its main diagonal. So with this, what we get is, we get the transpose of a matrix. You can see the transpose of the matrix here, which is denoted with M of t. And then what we'll do is, we'll reverse the columns of this transpose, meaning take the first column here in the transpose 1 2 3 4 5, right? So we just need to reverse this columns of this matrix. So it becomes 5 4 3 2 1. You can see it here. So like this, we will do it for all the columns in this transpose of this matrix. And then this is the actual rotated matrix 90 degrees counterclockwise. So this is how we are going to achieve the solution. So let's do this in terms of code. We have a matrix here. We have a class here, rotate matrix. And first, let's actually have a matrix. So you can see here, I declared a two-dimensional array M, and I have the elements here, 5 by 5 matrix, right? I have taken the same elements which we have seen in the example. Now, as the first step, we wanted to do the transpose of this matrix. We wanted to find the transpose of this matrix, right? So for that, I am creating a method transpose, which takes the matrix as the input. And then what we'll do is, we wanted to transpose this matrix, right? So transpose is swapping the elements like ij. So if we call I as row and j as column, so we need to swap ij with ji. So for that, let's say I represents my row and till all the rows. So m dot length gives me the row count, right? And let's declare another index j which actually represents columns, and we can take any row as it's a n by n matrix, right? So we can take any row here representing any row. So I am taking the first row, 0th row dot length, which gives us the number of columns, right? And till all the columns. So what we wanted to do here, we wanted to swap ij with ji, element at present at ij, I representing row and j representing column, with ji, right? So for that, how to swap is, so first we'll take I and j value into some temp variable and we'll swap ij with ji, or first we'll have ji, so ji with ij. Okay, anyway we captured ij into template. Okay, so ij into ji, and then we'll have ji equal to temp. We have ij in temp, right? So we are swapping m of ij with m of ji, so that we get the transpose of the matrix. Now we got the transpose of the matrix. All right, now what we need to do as a second step, we wanted to actually reverse the columns of this transpose of this matrix. So for that, what we'll do is we'll reverse. So we'll have another method where we'll call that method as reverse of transpose, which also takes the matrix. And then what we'll do is we wanted to actually swap the columns, right? Sorry, reverse the columns of this matrix. So for that also, we'll again take I as index, which represents like all the columns in it. For each column, so you can see m of 0 dot length gives me the column count of the matrix. And for each column, what we wanted to do, we wanted to swap, right? Swap the column, swap the, we take each column, and we, how do we are going to reverse the columns is, so let me go back. So we are going to actually reverse the columns by swapping. So you can see 1 2 3 4 5, right? So we'll swap 1 with 5. The first, we'll take the column will be fixed here, and then first element in the row, first row with last row element. So column is anyway fixed, right? So first row with last row, and then we'll increment the count. So we'll go to the second row, and from here we'll decrement the count, 4. So 2 4 will be swapped. So we definitely need two variables here. First variable will be fixed for the column, and we need two more variables which actually represents the the first variable will be incremented from top to bottom, and the second variable will be decremented from bottom to top. That's how we are going to swap and achieve the reversing of the columns, right? So for that, what I'll do is I'll take j as a variable which will be incremented from top to bottom, and we'll take another variable k which actually represents the last row and will be decremented, right? Length minus 1, we have to take length minus 1. And then when should we stop this? When j is less than k, then we'll stop it. And each time we wanted to increment j and decrement k, as k is starting from the bottom, right? Now what we wanted to do, we wanted to swap the variables, right? Swap the elements, m of j, and column is fixed, right? So let's first fix the column. So you can see I'm actually storing the ji into temp, and then ji will have the value as m of ki. Column is fixed, right? I is representing the columns here, so I is always fixed, and you can see j is representing a row here, so I am just replacing j with k here. You can clearly see it here, k of I. You can see my column is always I, and row is just I am swapping j with k, and m of ki should have the value of temp. That's how we swapped the values with j and k, and each time j is incrementing from top to bottom and k takes care of decrementing the value from bottom to top, and each time the elements get swapped until this condition is met, j less than k, right? And this will happen for each column that we are representing with the outer for loop, right? So this is how we are going to achieve the reverse of the transpose. That's it. We are done with the solution one. And to display this matrices, so we'll define one more method. So we wanted to view these elements, right? So for that we'll define one method to actually display the matrix. So I'll call this as display matrix, which again takes the matrix and displays it. So how should it display? Outer for loop for rows, I less than m dot length for all the, we wanted to display all the rows, for all the rows, and for each row in the, each column in the row, till all the columns are done, right? Length, j is representing column here, I representing rows, j represent columns. And now we wanted to just display m of ij, and we wanted to leave some space here, right? And once we are done with each row, we wanted to have a new line, right? This is how we wanted to display the matrix. So now we wanted to call this methods, right? First transpose and then reverse transpose. So we'll have a main method here, and we'll call the transpose of m, right? And then reverse transpose of m. And we wanted to display the matrices, right? So what we'll do is we'll just say before transpose the matrix is we are going to display the matrix, and then what we'll do is after transpose, just write after transpose, and we'll display the matrix again, right? And then we will also display the matrix once it is reversed. So I'll just say reverse transpose. All right, let us run the program now. And we can see the output here. Before transpose, we have the original matrix, whatever matrix we have given here, we can see it here. And after transpose, we can see it here. So over the main diagonal, elements got swapped. Let me make it big. You can see it here after transpose over the diagonal. So the elements got swapped, right? And after the transpose, we wanted to reverse the transpose. That is, we wanted to reverse the columns of the transpose, right? And you can see the output here. After reversing the columns of the transpose, we get the expected output of rotating the given matrix 90 degrees counterclockwise. So this is the first solution. Now let us see the another solution here for the same problem, which we call it as rotating the matrix ring by ring. So we can think of this given matrix as a set of concentric rings, and then we'll try to rotate each ring until the entire matrix is rotated. So we can see here in A, so the first outer ring we call it as ring 1, and the highlighted part inside it we call it as ring 2, or we will also call it as innermost ring, right? And you can see in the B part, how do we do this? We can start from the outermost ring and we'll work out our way inward. To rotate this outermost ring, right, we swap index by index starting from 0 0 0 0. We'll start it, and what we are going to do here is we'll move the right edge in place of the top edge first. So meaning 5, 10, 15, 20, 25, right? So this is what we call it as right edge here in this example. And then the top edge is 1, 2, 3, 4, 5, right? So we are going to replace this top edge with the right edge. You can see it here in B. So when we replace it, what happens? So in the first row or the top, we will get the right edge, meaning 5, 10, 15, 20, 25 will be placed in the top edge. You can see it here. And then in this, the bottom edge in place of the right edge. So the bottom edge 21, 22, 23, 24, 25, right? So this will be written here in place of the right edge. So you can see it here. This 5 elements got placed in the right edge, and then the left edge in place of the bottom edge. So whatever we have in the left edge, 1, 6, 11, 16, 17, 21, this will get it into the bottom edge. You can see it here. And finally, top edge in place of the left edge. So top edge we have 1, 2, 3, 4, 5, right? So that we'll get it in the left edge. You can see it here. It is placed here in B. You can see it clearly here. So this is what we'll get it after rotating ring 1. If you observe, the highlighted part of ring 2 remains same, still remains same. And then what we'll do once we are done with the outermost ring is, so you can see here when this process is done, the outermost ring is rotated by 90 degrees counterclockwise. We can check here. And then in the C part, we can see we'll pick up the ring 2 or the innermost ring, and we'll start it from the index 1 comma 1 now. So earlier 0 comma 0, right, which starts with 1 in our case. The value is also 1, and in this case, in the highlighted part is called as innermost ring, and 1 comma 1 index is representing 7 right here. And we'll actually follow this process of B, whatever we are doing here, the moving of the elements. So we rotate the elements of the innermost ring as well. And finally, after rotating the ring 2, also following the same process, so we'll get the resultant matrix. You can see that in the C, represented with C after rotating ring 2, and this is what the resultant matrix is. That is rotating the matrix 90 degrees counterclockwise. So let's see this in terms of code now. For now, what I'll do is, from the main method, I'll actually, comment this out for now. I'll also display the matrix for the first time. All right. So in order to do this rotating matrix ring by ring, so we'll actually write a method. We'll write a method which I'll call it as rotate a ring, which takes the matrix as parameter, and then first we'll find the length of the matrix. That we'll store it in some variable called length, and then we'll start it with the one outer loop which actually represents the rings, how many rings we wanted to do it. So we, for any given matrix n by n, so we'll be having the length of length of the matrix is m, so we'll get m by 2 rings. So we wanted to do this process for all the rings. So I'm taking ith as index, and so till, and to represent this for the rings, number of rings, and the number of rings we get it is the matrix size divided by 2. So we can see the condition here. So this outer loop or the ith index keeps track of the number of rings, and then we'll have another inner loop with index j, which should start with I. Now what we are doing is, within this inner loop, we wanted to perform that logic whatever we have seen in as a part of solution, right? So you can see here, as a part of solution, we wanted to do some operations, right? So replacing right edge in place of top edge, bottom edge in place of right edge, all these 4 operations, right? So we are going to do that within this inner loop, and this has to be done till length minus the total length of the matrix minus I, and for all the columns, right? So now what we'll do is, first thing is, so let's see this here. We move the right edge in place of top edge. So we are going to replace the top edge with right edge. So now what happens? We'll use top edge, right? So first we'll actually store the top edge. We also need top edge because this top edge at the end we'll actually have that as the left edge, right? So I'm storing it in the temp variable now. So let me also write the comments here. So first thing what we'll do here is we are going to move top with right. We are going to replace top with right. So how are we going to do that? Top is represented with ij here. So I is representing the row, right? And j is representing the column here. So the top edge, we are going to replace it with right edge. So how are we going to get the right edge? Is j representing the row and length minus 1 minus I. So this is how we are going to replace the top with the right edge. So this represents the right edge element, right? Now right should be replaced with bottom. You can see here. So once we are done with this step, the bottom edge in place of the right edge. So right edge should be replaced with the bottom edge. So how do we get the bottom edge? Is m of length minus 1 minus I. So gives us the bottom edge row. Let me write it here. Bottom. So right. So we are going to replace right edge with bottom, right? And length minus 1 minus j. So with this, what happens? So this represents the bottom edge, right? So we can see here in this matrix. So this is the bottom edge, right? So this has to be replaced. So the right edge should be replaced with this bottom edge, and we are going to read this from right to left each element. That's the reason we have it as length minus 1 minus I, which is like fixed, and then length minus 1 minus j is like incremented, or this is actually decremented from right to left. And then once this is done, we wanted to replace this bottom with left edge. We can see it here. So we are done with the second step, and now left edge in place of bottom edge. Left edge in place of bottom edge, right? So we have bottom here, and this we wanted to replace it with the left edge. How do you get the left edges? This is the row of it, and then I representing the column. And finally, what we'll do is we'll replace this left edge with the top. And how do we get the top? We have it in the temp, right? So this is the left edge, and we are going to replace it with the temp, where we have the top edge. So these are the 4 operations we'll perform till the complete outer ring, or till the first ring is done. So if you see it here, we are not actually rotating the entire edge here. We are rotating element by element. For example, you can see here 1, 2, 3, 4, 5, right? So the first thing what we are doing here, we are moving right edge in place of top edge, right? So in place of top edge, we are going to have the right edge. So if you observe here, this 5 gets moved here first, and then comes the second step, bottom edge in place of right edge. So here 21 is rotated here or moved here first. So in each operation, one element is rotated. So you can see it here. That is done by this inner loop. So each time this inner loop, one element in the matrix gets moved according to this logic. And once this inner loop is done, so the one ring will be done. And this will continue it for all the rings. And we already said ith index represents the rows. rings, right? This represents the rings. So this process will perform for all the rings. So this is how we are going to rotate the matrix 90 degrees counterclockwise. So we wanted to call this method in the main method, right? So let's do that now. We'll first display the matrix and then we'll rotate the matrix and then we'll display the matrix again. Let us execute this program now. Okay, I already have this 2 times. Let me execute this again. And we can clearly see here, we didn't give the, okay, let's actually give some new line character here whenever we wanted to display the matrix. So what we'll do is we'll just give a new line character so that it will be clear. The output will be clear, right? So you can see it here. This is the original matrix and this is the rotated matrix. So you can clearly see the output here. And this is how we can rotate the matrix ring by ring. And this is our second solution. And this is how we can solve this rotating the matrix 90 degrees counterclockwise in 2 solutions. These are the 2 solutions. That's all for this video. Thanks for watching.